In this video, I'm going to be talking about planetary motion. And before we get started into that motion, I would like to talk about celestial objects. One of the things that we will be talking about a lot about and you hearing is the word celestial object. What exactly are they? They are anything outside the Earth's atmosphere. Sun is an example, the moon, stars, and planets are all considered celestial objects. So in this video, we're going to be talking about apparent motions versus real motions. And here's an example of an apparent motion. Each day the sun rises out of the east and moves across the sky at 15 degrees per hour and will set in the west. We see that every day. It's an observation that we see. But the question is, what is the real motion? Is the sun really moving around the earth, or is there something else? Here's another example of apparent motion. Here's the night sky. You can see the stars moving. This is special photography to show you the movement of the stars around a central location, Polaris. Again, celestial objects that have an apparent motion, that they seem to be moving around. So what is the real motion? And hopefully you have determined that it's actually the Earth's rotation that's responsible for those apparent motions of the celestial objects. Remember, the Earth is rotating on its axis that is tilted 23.5 degrees from vertical and slowly rotating 15 degrees per hour. And because of that rotation, the sun, the moon, the stars will move across the sky at 15 degrees per hour as well. So I'd like to show you how to find Polaris in the night sky. Here's a quick little image for you to look at. Take the end pan handle, or the pan of the Big Dipper. You'll look up to find the Polaris of the handle of the Little Dipper. The other question you might come across is, where will Polaris be in 6 months? Because the Earth is rotating and revolving, each night at 8 o'clock, if you were to view this at each night, the Big Dipper will change and be in a different portion of the sky around Polaris here at the center, and in 6 months it'll be right across from its position here. So how do we know the Earth is rotating? The first piece of evidence is the Foucault pendulum that you're observing here as I'm speaking. It is a free swinging pendulum that is moving back and forth and will keep doing that until some outside force is acted upon it. And it will slowly over time knock down each of those spheres that you see there, because they are attached to the Earth and they are rotating with the Earth. It'll move back and forth and hit one peg and then hit the other one on behind it on the other side and slowly go around almost like a clock. The next one is the Coriolis effect. So here's a short little video clip that I'd like you to watch.
The path of the ball appears. To an observer above the merry-go-round, the path of the ball appears straight, while to someone sitting on it, the ball appears to curve to the left. This exemplifies the Coriolis force, whereby, to an observer on the rotating Earth, the path of an object appears to be deflected, and this is a result of the Earth's rotation.
So Coriolis effect for the Earth is being deflected from a straight line because of the curvature. In the northern hemisphere, it is deflected to the right, and in the southern hemisphere to the left. And we'll talk more about that as the year goes on, but it shows its evidence that the Earth is rotating. The other motion of the Earth is the revolution around the sun. It's doing that once every 365 days. And how do we know? The evidence that we have is the seasonal changes in the constellations. We have winter constellations like the constellation Orion is up in our night sky. And in the summertime we have another set of constellations, because as the Earth moves around the sun, our nighttime is looking out into a different portion in space. The other one is the apparent change in diameter of the sun, and we'll talk more about that when we talk about the shape of the Earth's orbit around the sun. We'll be doing that tomorrow, and then this will make a little bit more sense to you. So the last segment here is retrograde motion. And this is what happens when the Earth is moving in orbit closer to the sun and moving faster than compared to Mars's orbit. And it will wander about the stars here, but it makes a backwards motion, and that is called retrograde. And that is something that is an apparent motion because of the Earth's revolution around the sun in a path that is shorter